I want you to think about what it's like to go for a walk in the rain. Not so hard when you live here in Vancouver. Now, think about what it's like for it to be raining and then you walk inside a forest. Suddenly, the rain is a lot less intense. The water might be falling around you and the ground is still wet, but a lot of the rain is getting intercepted by the canopy above. This intercepted rain is either evaporating back into the atmosphere, dripping down a tree stem, or falling through to the forest floor. This interaction between vegetation and precipitation is greatly important for our water cycles and water availability. In snow-dominated regions like the southwestern interior of British Columbia, vegetation influences snow melt and snow accumulation. These processes are important for water availability in the late summer when precipitation is low, as well as flooding in the early spring when we get these large melt events. When disturbances occur, like wildfires, pest outbreaks, or human activity, these changes to the forest composition can alter the way that water moves through a watershed. So for land managers, it's important to understand when a disturbance occurs, one, how does the forest recover? And two, how do hydrological systems adapt as the forest regrows? A way that we think about this is often using hydrological recovery. We can say that a forest has recovered hydrologically when the hydrological conditions return to pre-disturbance characteristics. However, our current models are limited in their ability to model hydrological recovery because of oversimplifications of two key factors: the rate and behavior of vegetation regrowth. My research looks to fill this gap by using satellite imagery and LiDAR, or light detection and ranging, to map vegetation regrowth through time using a key ecological indicator called Leaf Area Index, or LAI. LAI is the leaf area per unit of ground area. So if I was standing in a forest, the leaf area index would be the number of leaves above me in a vertical column. LiDAR provides us with fine-scale 3D structural information about the canopy, like LAI, and satellite imagery provides us with continuous monitoring of LAI through time. I harness these data sets together to get a better understanding of how vegetation is regrowing, and then I use this to parameterize a hydrological model. I can then model different disturbance scenarios to understand how specific changes in vegetation alter specific hydrological processes. More accurate models allow us to do a better job of understanding how human activities and climate change alter the water cycle, and we can use this to inform critical management decisions for natural disaster resiliency and forest management. Thank you.